So in this video, we're going to talk about how to factor a quadratic expression when a is not 1. So in this case here, we're given a quadratic expression in standard form, which is ax squared plus bx plus c. And so we can easily see that in this case, a is equal to 3, b is equal to -5, and c is equal to a -2. So factoring when we have a form like this and a is not 1 is very different from factoring when a is 1. When a is equal to 1, we simply find the numbers that add to b and multiply to c, and then we can jump right into creating our factors. Unfortunately, when a is not 1, the process becomes a little bit more complicated. So instead, what we're going to do is we're going to use what's called the grouping method. So I need to find numbers, again, that are going to add to b. So blank plus blank equals -5. But instead of multiplying to c, I have to multiply to ac. So in this case here, a is 3, c is 2, so 3 times -2 is going to be -6. So I need to find numbers that are going to add to -5 and multiply to -6. So those numbers are going to be a -6 and a +1. And it doesn't really matter what order you put them in, but those are the numbers that we need to use. So what we're going to do now is we're going to take this middle term, this -5x, and we're going to split that up into the -6x and the +1x. It doesn't really matter which way you do it. You could do it the same order you have here, or you could say I'm going to use the 1x first and the -6 second. Doesn't matter. Okay, but we still have this -2 on this end, and we still have 3x squared on this end. It's a +1x. So really, I haven't changed anything about the expression other than the way it looks. If I were to combine my like terms here, the 1x and the -6x, it should equal this -5x and end up right back where I started. But the reason I wanted to do this is I wanted to create 4 terms so that I'm able to group the first 2 and group the second 2. So what I'm going to do from each set of parentheses now is I'm going to factor out the greatest common factor. So if I look at this first set here, 3x squared plus 1x, the greatest common factor there is just going to be x. So if I pull out x, I'm left with 3x plus 1. In this set of parentheses over here, my greatest common factor would be 2, but because the first term is negative, I want to pull out a -2. And so this would leave me again with 3x plus 1. This is kind of the first point where I get to check to make sure that I'm doing the work correctly. If I've done my job right, the parentheses should be exactly the same. And so in this case, they're both 3x plus 1. If the parentheses are different, whether it's just a number or a sign, if they're different, that means that I made a mistake somewhere along the way. I need to go back and find it. So now, this 3x plus 1, the highlighted piece, becomes the new greatest common factor. So my first factor here is going to be 3x plus 1. My second factor is going to be made up of the leftover pieces outside. So in this case here, that's going to be x minus 2. Okay? So I've taken my quadratic expression and I've completely factored it down to this right here. If I were to redistribute this, or FOIL as some teachers say, I would end up right back where I started. So this expression and these factors at the bottom here, these are equal. Remember, as we said earlier, the order of these two middle numbers, the 1x and the -6x, does not matter. It might mean that my work in this step looks a little bit different if I had switched those, but my result at the end would be the same. I might just get x minus 2 times 3x plus 1, but based on the commutative property, that doesn't really matter. The one thing I want to add is if we originally had a quadratic equation rather than just an expression that we were trying to solve, well, we have an equals 0 at the beginning, which means we have an equals 0 all the way through. And just like in my other factoring videos, we're going to see at this point here, we're going to use the zero product property in order to solve. So we'll say that 3x plus 1 is equal to 0 and that x minus 2 is equal to 0. So this here is going to be 3x equals a -1, which means x equals a -1/3. Here we're going to get x is equal to a +2. So my solutions are x is equal to a -1/3 or +2. Okay, and Again, these are the zeros or the x-intercepts of the function. These are the numbers that if I were to plug into this expression would come out to equal 0. So that's it. That's how you're going to factor a quadratic expression by grouping. I want to make sure I thank Allie for the idea of coming up with these videos. Allie, I hope they helped you, and I hope they helped everybody else that watches. Thanks.